Alrighty, so we're going to learn how to geometrically add vectors. Vectors in general look a little like this. They look a little like rays. That could be considered a vector. Vectors always have magnitude, which is kind of similar to the length. So if this was 5 centimeters, that would be the magnitude. And they also have an amplitude or direction. So I'm going to pretend this is 30 degrees. I didn't actually measure it, but that would be your amplitude, and that would make this a vector. So now we're going to try and add vectors. Geometrically, of course. So let's say we have this vector at roughly 80 degrees, and we'll say 3 centimeters. I don't know how much that is really, like I'm not going to measure it, but. And this is 20 degrees, we'll pretend, and let's say 2.5 centimeters. So we'll put 3, and we'll put 80, and then we'll put 2.5, and then we'll put 20. Now to add them, vectors need to be kind of moved around a little bit, and that's okay. You can move vectors around. When you move vectors, be careful that you line up head to tail. Always. Head to tail. So this would be the head of my vector right here. And that is the tail. The thing with the arrow is showing the direction. It's the head. Where the vector starts is the tail. Always remember that. So this is my 20-degree one. And it's at 2.5. And then from here, we make the second angle, which is 80. So you measure the 80 degrees from the other point. Notice how they're lined up head to tail. So the head of the second vector is touching the tail of the first vector. And I didn't, as I said, I didn't like measure this out to make sure it's exact, but you get the basic idea. Now, you can line up, when you do a resultant vector, it goes from the tail of the first vector to the head of the second. And more often than not always, but more often than not, with two vectors, it forms a triangle. Now, we can use a ruler and a compass to measure the angle from and the distance, which, keep in mind, are called magnitude and amplitude. I'm not going to do that right now because I don't have an online protractor, an online ruler, but we'll pretend that, let's say it's 5 centimeters. If I measured from like here to here, and then if this is the 0-degree mark, I put my protractor down, and let's say I measure this, it comes up to be, I don't know, 60 degrees. And that would be my answer. It would be 5 centimeters at 60 degrees. To subtract vectors, you do much the similar thing. The only thing that's different is that you have to make the vector that's being subtracted opposite of what it normally is, because it's negative. And to create an opposite vector, you add or subtract 180 degrees from what the actual measurement is. So we're going to pretend this one's 40. We'll say this is 5. We'll say this is 20. At 2. I don't really know what they are, but to subtract, let's say this one from this one, you make your original 40 degree 5, I guess centimeter, I didn't label them, but you can put centimeter vector. And then from that point, you have to put this vector in, but you have to add 180 degrees to it. So 20 plus 180 is 200. That kind of looks right around there. It should be going like basically the opposite way. If you put them together, if you put this vector right next to that one, it should form like a straight line like that. And that should be 200 degrees, and that would be 40. Now, all you need to do is line up your resultant vector. Make sure the tail goes with the tail of the first vector, and the head goes with the head of the second vector. And then you could use a ruler to measure how long this is, and that would be your magnitude. I'm going to pretend that it's 1 3/4 because I don't know. And I'm going to pretend that this angle is 110 degrees. You'd actually measure it out in real life, but so my resultant vector would be 1 3/4 centimeters. For magnitude, and then 110 degrees for amplitude and direction. Amplitude and direction are pretty much interchangeable. So that's how you add and subtract vectors. Cool? Cool.